Hi there everybody, and welcome to this tutorial on similar triangles. Now in mathematics, similar doesn't just mean kind of the same, it's got a specific definition, okay? And the definition for similar triangles is to have congruent angles but different side lengths. And as far as we're concerned for just now, the word congruent just means exactly the same. So that means that even though these sides are different sizes, so you can see there that this 12 and the 24, that's like the same side in the triangle, but they're different sizes. It's twice the size, see that? And then 5 and 10, and 10 and 20. So I hope you can see that you've got like a scale model of each triangle. And this one is twice the size of the little small one. But I hope you can also see that the angles here are the same. The angles here are the same. And the angles right here are the same as well. So that's what similarity means. Different size lengths, but the same size angles, and usually there's like a scale between them, so it's like twice the size, or 3 times the size, or 4 times the size, or something like that, okay? And there's a little bit of maths we can do round about that. So if we look at this example here, we can see that we've got two triangles. One is a reduction of the other one, so if we look at this one, if I'm saying reduction, that means that's smaller by some kind of factor, alright? And how we get the scale factor is we look at pairs of corresponding sides. Now, what are corresponding sides? Well, all that is it's the same side on the different triangles that kind of go together. Does that make sense? So, this 8 and the 6.4, and then, I'll make that a different colour. So here we can see the pairs of corresponding sides. So the 6 and the B are corresponding, the 8 and the 6.4 are corresponding, the 7 and the A are corresponding. So it's like the same side, but on the different triangles, alright? So that we can establish our scale factor, we first have to look at corresponding sides that have numbers on them, alright? So this is 8 and 6.4. The other pairs of corresponding sides don't have numbers on them. Right, so we're just going to work out this scale factor first. Now we can see that going from this triangle to this one is a reduction in size. So that means that the small number is going to go first in our scale factor. So this is how we write that down. Okay, so we take the two sides, we take the 6.4 and the 8, and we divide them. Okay, can you see that fantastic 8 there? That was so good. So the 6.4 and 8, and we divide them, but we have to be careful that the small number goes on top. See that? For a reduction in size, because that's going to make the scale factor less than 1. Okay, and that's going to be important in the next step. So if we're going to simplify that, we just divide it, and we get 0.8, which is another chance for me to do an 8. Don't laugh at my 8s. So that's scale factor 0.8. Okay, so all that we've done there is we've done 6.4 divided by 8 to get a 0.8, and how we've known it's 6.4 divided by 8 is because it's a reduction in size, so that means that the small number, the smallest one, is going to go on the top of our division. Alright, so 6.4 divided by 8, and it's 0.8. So remember, a factor is a number that we multiply. So in order to find the missing sides, all we have to do is we multiply the corresponding side by the scale factor. So let's say we want to find side B. So we want to find side B, and the corresponding side to B is 6. So in order to find side B, all we need to do is we do 6 multiplied by 0.8. I should have really practiced my 8s before I did this. And the answer to that is 4.8. Now there's no units just now, so we're just going to leave it as 4.8. Now we're going to look at side A. So side A, the corresponding side is 7. Okay, I hope everyone can see that that's 7, that corresponds to the A. So that's A is going to be equal to 7, because that's the side that corresponds to A, times our scale factor, which is 0.8. which gives us 5.6. Alright, now with scale factor questions, it's really important that you check that all the answers make sense, alright? Because sometimes a common mistake is that you make a side big that should be getting smaller, and you make a side smaller that should be getting bigger. So if we look at 7 and A, then we know that A should be smaller than 7, and if we check our answer it's 5.6, and it is, and B should be smaller than 6, so it's 4.8, and it is, so we've not made it bigger by accident, alright? And that's a big check that we've got to make sure we do every time we do a scale factor question, alright? So remember, if you want to pause this, just go back and pause it and copy down the solution into your notes jotter and make sure that you understand that, alright? So this time we've got a little bit more harder example. And this is quite a common thing in scale factor questions, and what is done is you've got a triangle sitting on top of another one, alright? So this is how we're going to cope with this particular example. So you can see here that what I've done is I've basically split the two triangles up. So if you imagine that it's like one triangle lying on top of another one, so the small one here is just lying on top of this big triangle here, okay? So the little small one is laid on top of the big one, and all I've done is I've split them up so that they're now two separate triangles. So the next big question is, this side used to be 12, don't know what happened there, sorry. This side used to be 12 and now it's 18, so how did that happen? Well, it's dead simple. Look what I've done, I've got 12 centimetres here, I've got 6 centimetres, sorry that's metres, 12 metres there and 6 metres there, and all I've done is I've added them together because this is a whole length from A to D, right? So the whole length of the big triangle is 18, okay? I hope everyone can see that quite good there, right? So I've done 12 and 6, added it up to get 18. A common mistake is that everyone thinks that this full length here is 18, and it's not. We've got 12 and the 6 metres add together to give us the 18 metres, alright? So just remember that when you're splitting these up. Okay, so let's move on to the actual solution then. So if we look at the last example, all that we did is we looked to find a scale factor first of all. So that's what we're going to do first. So we need to write down scale factor. And in this case, the scale factor is coming from a pair of corresponding sides. So we need to look at our corresponding sides. So the 0.9 and the h corresponds. We're going to use that later. And the 6 and the 18 are corresponding sides. So we're going to use the 6 and the 18 because obviously they're numbers to figure out our scale factor. Now if we want to go from 6 to 18, we're obviously making that bigger, and I think you've already probably worked out what the scale factor actually is. So let's write that down. So 18 over 6, and the 8's are getting worse. So we've got 18 over 6 as a scale factor. Remember, all we do is we make a fraction between our two corresponding sides, and if it's getting bigger, then we put the big number on the top. If it's getting smaller, as you've seen in the last example, then we put the smaller number on the top. So in this case, it's an enlargement, so we're getting bigger, so the big number goes on the top. So that's 18 over 6, which is 3. Okay, so it's a nice simple scale factor this time. So I hope you can all see that 6 to 18, that's an enlargement of 3 times, so it's 3 times as big, so we need to do the same to the 0.9. So all we need to do is we write down h is equal to 0.9 times 3, which gives us 2.7 metres. Okay, so it looks like in this question we've got the height of a balloon or something like that, so we can see that the height of the balloon in this case is 2.7 metres. So that's scale factor. So remember, just go through the slides that we've shown, make sure you understand what similar triangles are. So remember, that's triangles that have the same angles but different size lengths, how we can make a scale factor, and then how we can figure out sides that are missing in our triangles. Okay, thank you.